Hey everyone, welcome to Cloud Masters. I'm your host, Matan Bordeaux. I'm joined by my co-host, Sam Clark, and as well as two database experts, Paul Alzina and Kate Gavron, recurring guest. We're here to talk about RDS, specifically things that you should take into account when optimizing your RDS clusters. So we're going to be talking about performance, of course, costs, and things like that, and so on and so forth. So first things first, a two-part question. Feel free, whoever wants to take this, but maybe let's quickly highlight RDS versus Aurora. And secondly, what framework should you use, or should a company use to make the decision with whether to go with RDS or Aurora?
So basically, what's Amazon RDS? So RDS, to start with the first things, it's a relational database service, and it's a AWS service that it was released on 2009, so quite ago. And basically, this offers it's a managed database service that is used to set up relational databases in the AWS cloud. So basically, it's the place that you should go if you would like to create a database instance to run your workloads. So before this service was launched in 2009, so all the customers had their database instances running in EC2 instance, but this had some drawbacks to have their database instance running in EC2 because they had to basically manually do a lot of automatized, so a lot of administration tasks back then you needed to do it manually, basically. For example, provisioning a new database instance, removing them, configuring parameters. Also, in terms of backups, you needed to choose which was the retention policy to make sure that all the backups were stored in the right way. Also, in terms of patching, you had to basically make sure that all the updates that you needed to make, for example, updating minor or margin versions, so you were following the right path. And this involves so a lot of people. For example, back then, you needed a big team of DBAs, database administrations, to do all this kind of manual tasks for all your database clusters, basically. So Amazon RDS basically, and they noticed that they could basically automatize all this kind of things, and they released this kind of services. And this is why it's a managed database service, because it automatizes provisioning, configuring backups, patching. So this is the place you should go if you would like to have your database instance created in the right way. Amazon RDS, it is available in different flavors right now. So it's available on MySQL, Postgres, MariaDB, Oracle, Microsoft SQL Server, and the last one, it's IBM DB2. So this is a little bit what it's Amazon RDS. And then we have also Amazon Aurora. So Amazon Aurora, it's, I would say, a new set of database engines that it was released on 2014, so 5 years after launching Amazon RDS. And basically, Amazon Aurora, what it is, it's a proprietary relational database service offered by AWS. And it's only compatible with two database engines, so with MySQL and Postgres. And you need to think about Amazon Aurora. It's like, I would say, it's a high performance relational database. So you could have your RDS MySQL or RDS Postgres, but now you have also the option to have Amazon Aurora MySQL or Amazon Aurora Postgres. And if your priority is regarding performance, if you would like to have the best of the best out there in AWS, you should go and use Amazon Aurora, because it's much faster than using RDS. And how Amazon Aurora achieves this kind of improved performance? Basically, AWS engineers, what did in the past is that they re-architected so all the system involved in a database engine, basically. So what they did is to extract all the layers involved. And for example, to put an example, a storage layer, Amazon Aurora, it uses a storage cluster subsystem. So unlike, to put a comparison with RDS, so RDS, all the storage is stored in EDS volumes. But in Aurora, basically they extracted all the backend infrastructure in terms of storage, and this storage they have been able to optimize it the most, basically. And in terms of durability, there are some kind of perks, because using Aurora, you have all your data replicated 6 times. So for each availability zone, 3 availability zones, so you have 2 copies of your data. So Amazon Aurora, what it ensures in the end is that your data will be stored whatever it happens. So you can be sure that you won't lose any kind of data. And another important thing about Amazon Aurora is that it's fully compatible with RDS. So let's say you have your RDS instance, a MySQL or Postgres, and you would like to improve your performance. So AWS offers a quick way in order to migrate your RDS to Aurora. Basically, with 2-3 clicks in the platform, you can achieve this without any kind of downtime, incurring any kind of downtime.
Is it just like of asking yourself, do I need high performance? Yes, go with Aurora, or what is the framework for making that decision? Is there anything that maybe customers get wrong that you've worked with? Like the factors they miss out on some factors. They don't think about some things before deciding on RDS versus Aurora.
Yes, there are different things that you need to think about it. So I would never recommend anyone to, just go directly with Amazon Aurora, because it's the best you can get. So it always depends on your particular use case. For example, if you are using RDS MySQL and the performance that you are getting is quite right, so probably you don't need to go to Amazon Aurora, because yes, Amazon Aurora, it offers a lot of different perks, but you end up paying more money, because you won't get this service by paying the same as with going with Amazon RDS. So it depends on each customer use case. And basically you can decide by taking a look at different metrics. One of the most important metrics that we will take later is the IOPS, the total IOPS, so the total input operations per second that a database can receive. And based on this kind of metrics is when you can take the decision with, maybe RDS in getting some kind of bottlenecks, so maybe going with Aurora would be better.
Diving into RDS, because that's kind of, we did an episode with Kate and another database expert. Why am I forgetting the name? Amir. I remembered his last name, Haroon, more than so we covered Aurora previously, so I want to take a deeper dive into RDS. And so maybe Kate can answer this. Like, what should if someone's using RDS, what should you consider when you're optimizing performance and you're looking to optimize performance of your RDS instances?
Yeah, well, I think the first one is really having a look at like the instance type. So as well as the instance size, you have instance classes as well. So it's 2 really big areas to look at. So the instance size obviously governs really sort of how big that instance is. And the class governs like the split. So for example, if you're running a like a T class instance, then they tend to be the smallest ones. They have things that are known as burstable, which means for short periods of time, if you suddenly hit it, you get a really big query, something like that. They can sort of expand up a little bit. You get a bit more performance. But if you were to run it flat all the time, you'd run out of balance. And effectively, then that performance would be throttled. Another option is you have like the M class, which is effectively like your general purpose like class. So there you get a good balance of CPU and memory. You also have memory optimized, CPU optimized classes, and even in some cases, ultra high performance classes. So it really helps to understand your workload. If you're running a lot more of your queries in memory, if you're using a lot of database buffer cache, for example, and using a lot of repeat queries, then you may want to have a larger memory instance versus CPU, because that would probably work better for you. And then you need to size it appropriately. So sizing is always a bit tricky, because as most people probably know, instance sizes in AWS effectively double with each one. So a 2XL is twice as large as an XL. And this can actually make it quite difficult. If you're running, say, 45% CPU, could you get away with going down an instance size? Because in theory, then you might be running at 90%. Is 90 too hot, or is 45 wasteful? And that's really, a lot of that's going to come down to what you need, like how much risk you're prepared to take as a business, and really what your cost versus like reward, like risk versus reward metrics are, you could risk, like, as I say, you could risk making that instance class smaller and taking a potential small performance hit with the knowledge that you can always scale back up again if you need to. I think that is something that's important when you're looking at the cloud, is how easy it is to make those changes. So it's quite simple to make changes up and back down again with a short amount of downtime, which is important. None of these things are instant. If you want to talk about that, then we'll need to, you need to start looking at replication between instance types. But in general, making changes to instance classes, especially if you stay, to instance sizes, if you stay within the same instance class, that tends to be quite a quick change because of how AWS manages that under the hood. If you're changing your instance class, your instance type, that can take a little bit longer because normally that requires an actual sort of migration internally. So if that is something that you're looking to do and you do want to minimize the downtime, first thing is obviously test it. That's hugely important. I don't think we can say that enough. Any changes you make need to be tested. And then it's really important to look at, can you handle the downtime? So you would test this first with similar data volumes and a similar workload. Test it, time it, see how long that change takes. If that's acceptable, do that. Always go with the easiest option available. Don't make it more complicated unless you need to. But if that's too long and you really can't afford that amount of downtime, then it's definitely worth looking at things like replication. So some options, you've now got the new blue-green options within Aurora and RDS, which allow you to effectively create like a blue-green environment. So your blue is your current live, your green is where you switch to. You configure the green, you make the changes there, everything stays in sync, and when you're happy, you just switch over. You can also use things like DMS, which is like the database migration service, which again allows you to keep that sync between the two databases. Or you can also use some native replication if you wish to. That isn't blocked on either RDS or Aurora for most of the database engines. You can actually build out like your own native replication if you wanted to. I'm not sure whether that's worth it in most of these use cases. It's complicated. It tends to be a lot harder, but it is worth doing, particularly if you're really short on costs and you can't afford things like blue greens or running DMS. So that's sort of like really like the three options if you wanted to upgrade that without any downtime.
I was wondering, does also choosing the right instance type, does it also depend on whether you're doing production or some non-production environment?
Yeah, it can do. I mean, I mentioned that you have the T series of instances where they're known as burstable. So you don't get a guaranteed performance. Your performance level can spike up and down. And if you use it too hard for too long, then effectively it gets throttled, which can obviously have a huge impact on a production. So in general, the T classes are not normally recommended for production workloads unless you know it does suit. Some companies run extremely important databases, but they're very small and they know that they won't hit those limits, and therefore a T might be the best fit for you. But actually, if you look at some of in particular, when you start getting to like the T3 like larges or the T4 larges, and you have a look at those compared to an M6 or an M7G large, the price is really quite similar. It's not that much cheaper anymore to go for the T instance. So I think it really depends, again, on really like looking like nice and exactly what you need it for, but in particular, looking at your workload and your spikes. If it's suddenly short spikes, like occasional, then actually a T class might work well, because with that burstable, you get a little bit more power to perform whatever it is that you may need for that short period. But if it was sustained, then you may find you start hitting those limits and then you get throttled.
So speaking of looking at your workloads, what should I look at? Like, what metrics should I actually look at when I'm analyzing my RDS resources?
Well, the first ones that I mentioned was around like the CPU utilization. So again, it's a difficult one. I always say this, that the most efficient instance, this is true of a server or a database, is effectively a server that's running at 100% everything, but no one complains. And it's the no one complaining part that's really important, okay? Because we build services and we build applications for people. You don't just build a database for its own sake. So if no one is complaining and all of your application metrics are being hit, then maybe you don't need to worry so much if your CPU is very high. But in general rules, you want to be keeping that below 80%. And in fact, anything much lower than 80%, then you might want to look to see if you could consider downsizing that, or consider if maybe you could merge some databases together, put more databases on the same instance, for example, to use that CPU more efficiently. 80% gives you some room to spike up without everything hitting 100% and maybe getting like errors. And if you run at a high CPU for a long time, that can have an impact on the OS. So there's obviously an operating system that runs underneath that your database sits on. On RDS and Aurora, you don't have access to that, but it still exists. If you run any server at 100% CPU for a long time, it tends to fall over. Eventually, it tends to just run out of power and just gives up. And that's exactly what happens on Aurora. It's not the database that runs out, it's the operating system underneath. And then the whole server effectively falls over and you have a failover. So normally keep it under 80%. But if it's less than 50, then I definitely think you should look seriously into downsizing that instance class. And the reason why it's sort of 50 is that you're always going to have a small amount of overhead to run the database. It's normally somewhere between sort of 5 to 10%, depends on the database type. And that runs things like connection management. It runs the database software that's installed with the OS. Even like an OS doing nothing still takes a little bit of CPU. That still exists even when you go smaller. So by actually downsizing it, you actually give up a higher percentage of space, of resource to just running the OS. So you need to be quite careful when you're going to downscaling that you don't end up with actually reducing the available resource for your workload. So, but if it is less than 50%, it's still worth looking at in terms of downscaling. In terms of like freeable memory, that really depends. Ideally, you want to keep it above 1 gig, but again, you want to use as much memory as you can. Memory sat on a box not being used is wasteful. You're paying for it, you're not using it. Any DBA will know effectively the more memory you can give, the bigger your cache means that your database tends to run better. Queries and results can be pulled out of the cache, out of memory, rather than having to do disk reads. Disk reads are slow. More in memory, faster it runs, the better everybody is about the database, the more efficient you're being. And again, you want to make sure things like swap, you can use swap usage. It's really important to keep swap almost to 0. So swapping is where things that should be held in memory end up being written to disk, normally because you've got memory pressures. So if your freeable memory is quite low, you may find that swap starts to increase. Swap is bad for any database, for any server really. Swap is not a good thing to have. So free storage space. So you want to make sure again that you're not hitting storage bottlenecks. There are some mechanisms and ways that Paul's going to talk about later about how to manage your storage more optimally. And one that often gets missed a lot is around IOPS. So whilst on RDS, your IOPS are included in your price, whereas on Aurora, in some instances, again, we're going to dig into this a bit more later, on Aurora, in some instances, you pay for your IOPS individually. And actually, but the IOPS just has a massive impact. So the more reads you're doing to disk, IOPS is effectively how many operations per second are going to disk, reads or writes to disk. Now, disk reads and disk writes are both slow. So the higher your IOPS, that means the more data and traffic that's going back and forth to your disks, and that's likely to be a performance bottleneck. In theory, the lower the IOPS, writes have to be written to disks at some point. But if you're just doing reads and read IOPS, your aim would almost be to keep your read IOPS as low as possible. That means that things are more likely coming out of the buffer cache, which means they're being read from memory, which means your database is going to be performing better.
Now, let's switch to storage because you brought it up. Paul, how do I know if my RDS instance is experiencing a bottleneck?
Yes, this is an interesting
bottleneck.
question. Yep, because usually this is one of the things that it's mostly overlooked by everybody, really. Because when you want to decide if your database instance is running correctly, what you usually look are the metrics that Kate right now has shown to you. So CPU utilization, freeable memory, but usually the storage is one of the pieces that are, I would say, as important as the CPU utilization. And you should be sure that your database instance are using the optimal storage type. Because if you are unsure about all this, you could face a lot of issues on the storage. For example, the storage bottlenecks. So basically, what is a storage bottleneck and how it can happen? So basically, storage bottleneck, it happens when the number of IOPS, so the input and output operations per second, you need to think about IOPS like in a simple terms, like queries that you execute in your database instance. So when the number of IOPS that the database instance receives exceeds the capacity that the storage system can handle, basically what you have provisioned in your storage layer is where things can start going slow. So For example, if you have like a storage layer that only supports quite low IOPS, you could see that your database is starting to slow down, even having your CPU utilization level low. For example, you could see, okay, my CPU utilization is 30%, 40%. So, okay, it seems that everything is right, but everything is slowing down. So this is why it's really important to check the storage layer. And right now, I will show you the path that you should take into account to decide which is the optimal storage option for your database instance. So if you are not sure that your instance are using the optimal storage option, just try to follow these steps that I'm going to outline, and I'm pretty sure that you will be good. This will be a little bit techy, but I think it's really important to talk about of this. So basically, you have in RDS you have 4 storage options. 2 that are the general purpose storage volumes, such as GP2 or GP3, and then you have the provisioned IOPS volumes that are the IO1 and IO2. So here the question that you should be asking in your database instance is, when should I use one over the other? So the rules that you should follow are these ones, basically. So you should be using IO2 just when the total IOPS that your database is receiving are over 64,000 IOPS. And again, you can check the IOPS that your database is receiving by checking the total IOPS metric. This is one of the most important metrics. So if the total IOPS are over 64,000 IOPS, go with IO2. Then if that's not the case, I would recommend you to choose GP2 just only if the storage that you have provisioned is over 4 terabytes. And if otherwise, so if the total IOPS are less than 64,000 IOPS and the storage is less than 4 terabytes, you should be using GP3, basically. So this seems quite easy, right? But that's not the case, because there are other kind of considerations that you should be taking into account when using GP3. Let's say that you, following these steps, you decide that your database layer should be using GP3 storage type. Then in this case, you need to take into account the following, and this is really important. If the IOPS that are consumed by your database instance are larger than 3,000 IOPS, what you should do is you should increase your storage to 400 gigabytes. If you do this, if you change the storage to 400 gigabytes, automatically the RDS storage performance will increase. So instead of having up to 3,000 IOPS, your storage layer will be able to achieve 12,000 IOPS. So let's say that, okay, my storage of my database instance is already over 400 gigabytes. But I see that the total IOPS consumption is also more than 12,000 IOPS. Then what you should do is you should modify the instance, and you should provision more IOPS. With GP3 volume types, you can provision the amount of IOPS you want. So this is what you should do in this case. Modify the instance and increase the number of provisioned IOPS. And this doesn't cause any kind of downtime, and it doesn't affect the instance performance. So you can do it right away. And there's another final component with using GP3 volumes. And it's that the instance that you are using also matters. The instance class and the size. And why? Why is this? Because the instance have a maximum IOPS baseline. Okay, to put an example, let's say that you have a T4G medium instance. So T4G medium instance can only reach a maximum 2,000 IOPS baseline. So even if you modify the instance storage and increase the provisioned IOPS, your database instance won't be able to reach more than 2,000 IOPS because it's the maximum baseline. And this is something you cannot change. This is something that is defined by the instance that you are using. And all these limits per instance are present in the AWS documentation. So it's something you can go there, check the instance that you are currently using, and you will see the maximum IOPS it can support.
As you were talking, I was imagining like a decision tree just branching out in my head. that maybe we'll create a cool visual to go alongside that in a clip. But that was and
Okay,
this
yeah,
and this
sure.
is only for RDS, right? Because it uses EBS volumes.
Yeah, that's correct. Yes, because Aurora, the storage works in a complete different way. Instead of using EBS, it uses a cluster storage, and there are other considerations that you need to take into account, but only applies with Aurora. So what I have stated now, it only applies with RDS.
I always ask guests, especially if they work at DoiT, to share use any stories to kind of add some color to the best practices, the rules of thumb. And do you have anything where you had a customer experiencing
Yeah, sure.
significant RDS performance issues, and maybe even where the culprit was like unexpected, maybe at least for the customer side of things? Any
Yes,
stories
yes.
there?
Yes, I've got a nice story from a customer that I worked with a few weeks ago. That it was a customer that reported issues on their database instance. They had a production super critical for them database instance, and they noticed that everything, all the queries were being executed in a slowly pace. And they checked all the metrics, CPU utilization, free available memory, swap usage, and they didn't see any kind of issues. The CPU usage was lower than 50%. They had plenty of free available memory. They were sure that the storage layer had enough provisioned IOPS. So they reached to us and asking why their instance was still having these issues. And what we did, basically, we analyzed all set of metrics that we've got, and we realized something that it's what I have been explaining now previously, is that the culprit, it was the instance that they were using. Basically, they were using a small instance. Basically, I think it was a M6G, so a production class instance, but the size, it was a small. It was, I think, a large. It was a M6G large, something like this. And what happened? So the instance have a maximum IOPS cap that it can reach. So even besides that, they kept increasing the maximum number of IOPS. What happened is that the instance couldn't reach higher levels of IOPS. So in the end, what we recommended him is that he needed to basically scale up the instance or change the instance class to have to be able to unlock more IOPS, basically. And in the end, they did this, and by taking a look at the total IOPS metric, we were able to see that the total IOPS basically increased. So the instance was able to receive more IOPS. So this is super important because you always need to think about the instance you are using, because it's something that it really matters and that it can produce also a storage bottlenecks.
Yeah, if I think about that decision tree, they did everything right up until the last step where they didn't ask themselves, does this instance have
Yes,
the IOPS that I need?
yes, and it's because this last step, the instance also matters. This is something that also appears in the AWS documentation, but you need to do a lot of research to connect all these kind of points to realize that this is really important. And it's something that it's usually mostly overlooked by customers. This is something that I notice more, that they are doing the best they can in everything, the instance, a type, the class, also the storage, but they basically miss this last step, that maybe the instance they're using are capping the maximum IOPS the instance can reach.
We do occasionally call out for the cloud providers to do feature requests, assuming any of them ever listen to our podcast. But maybe it'd be a nice one for AWS here where, for example, if someone attaches an IO2 volume to a T2 medium that has a maximum throughput, maximum IOPS of 2000 as the baseline, maybe they could put up a warning that says you're wasting money here. You're never going to achieve it.
That would be great, because customers, since they see that they can over provision, keep provisioning more and more IOPS, They really don't know that there's another factor, that the instance, that it's basically capping the maximum IOPS. So in the end, the customer, it's wasting all this amount of provisioned IOPS. So they keep up paying more for something that the instance won't
And the
use.
pricing for those IO2 volumes is based on what's provisioned, not what's used, right? So yeah.
Yes, and IO2, for example, this kind of storage type, it's quite expensive.
Yeah.
So if you like to go to IO2, you need to be sure that you really need IO2, because IO2 can cost more the storage than the instance you are
Costs
using.
an awful lot more than a T4 medium.
Yes. It costs a lot, so you need to be really sure.
I just think a good thing to add just quickly on the IO2 before we flog this to death and Matan tells us to shut up and stop talking, is that actually on IO2 you have lower latency. So it's not just the IOPS, it's the speed of those requests. So IO2 has much faster latency speeds than GP2 or GP3. So again, it could be that, yes, that you need IO2 because you need faster read and writes, but it's not the number of them or the volume of them. It's just the individual ones need to be quicker. So just to bear that in mind. But yeah, your point about, if you go and attach an IO2 volume that's much bigger than the max capacity that your instance can handle, then you are still burning those extra IOPS that you're paying for, especially if you don't need them, but you might still need it for that latency. But it's not that common a use case. You typically have high IO volumes as well as the need for latency. You wouldn't typically need low latency on a few, but you might. Everyone's different. There's always edge cases.
Is it any less complicated with Aurora? Your kind of your best practices for storage?
Yes, in Aurora they are another, like Aurora has basically 2 modes to decide which storage you want to use. So instead of choosing either GP2, GP3, IO1, IO2, you basically can choose with 2 modes. One is the Aurora standard, and the other mode is Aurora IOptimize. And you need to select one of these modes either when you create a new Aurora instance, or you can also modify an existing Aurora instance and change the modes. And you need to be sure which is the best mode for your Aurora. And these modes basically only take into account how your Aurora cluster will be built. So it's not in terms of performance, but on which would be the costs in the end of the month that your instance will be built. And it's something that I see that most customers also tend to overlook, because it's something that if you take a look at the AWS documentation, you will see a lot of information. But in order to make this decision, to know which is the best mode for your database instance, the decision is not easy to take, because you need to do a lot of calculations. So to put here an example, let's say that you have an Aurora standard. You are using the Aurora standard mode. So Aurora standard mode, the way that it is built, it's you pay for the instance that are using. You pay also for the storage. So if you have more storage, you will pay more. And unlike it happens with RDS, here in Aurora, you will be paying for the IOPS. So if you execute, let's say, more queries, your cluster will be built. So you will end up paying more money for the IOPS. And this can cost a lot of money, because if you have like a production database instance that is receiving a lot of traffic, so the IOPS, number of IOPS will be super large, and you will end up paying a lot of money. And this could cause an issue, because yes, you are being built by the instance and the storage, but there are some times that if you have like an instance that is receiving a large amount of IOPS, just the part of IOPS that it's being built, it can be higher, just the IOPS, compared with the instance and the storage. And this can be an issue, and that's why what happened is that a lot of customers basically complained to AWS, and AWS realized that, okay, maybe we need to release another mode in order to make things a little bit simpler, or to adapt the Aurora, this design of product, better for the use case of each customer. And they released the Aurora IO Optimize mode. And Aurora Optimized Mode, you are also built by the instance, but the instance is more expensive than using Aurora Standard. Also, the storage it's expensive than using the Aurora Standard, but the IOPS it's free. You don't pay anything. So even if your database instance receives a lot of traffic, you won't be paying anything for the IOPS. But yes, again, you should know which should be the best mode to be used in your database instance. And basically, the question here to be asked is how I can know this, basically. And it's not easy. It's not really easy. And that's why customers usually try to choose one of the two modes, and basically maybe they don't pay enough attention. And there are two ways to calculate this. The first thing is you need to go to the AWS pricing webpage, get all the pricing basically for all these components, the instance, the storage, the IOPS. Then go to the AWS costs for your account, get what you have been paying for your database instance, and try to start making calculations to basically determine which of these two modes would be better in your use case. So to solve this kind of problematic, what we have done here in DoiT, we have, as we do with other kind of products, we have developed a Python application. It's a small script that basically does all this work for you automatically. So basically you specify which database instance you want to analyze, and it grabs the pricing, it grabs all the metrics from your instance, and in the end it says to you, okay, for your particular database instance, if you were to use Aurora Standard, you would end up paying this amount of money, and the same with IOPtimize. So using the script, it's really interesting because we have a easy way to know which mode would be cheaper in depending on the database instance.
Do you find that there's like a threshold with IOPS, or is it not as simple as that, or there are other factors I'm not thinking of? Because I guess because you're paying more for storage and for the instance itself, is it not just it's not as easy as just looking at the IOPS number. Otherwise there wouldn't be a need for a script, I guess, if I'm thinking out loud now.
Yes, it's really not that easy because the number of IOPS can fluctuate over the time. So it's something that you should be reviewing once in a while, I would say.
Kate, I think in the Aurora episode, think you brought up that I think if you don't have a prior history of using Aurora, was it to start with standard first and then see for a month?
No, it was to start with IOPtimize first.
Okay.
You almost remembered, right?
I got it mixed up.
So I mean, I was going to bring this up like briefly that it's interesting that so Aurora is like MySQL compatible or Postgres compatible. Okay, so it means that neither is really MySQL and neither is really Postgres. Okay, they are different database engines that have been built by AWS that mimic or are fundamentally different from the RDS versions of MySQL and Postgres. To do with how the Aurora storage layer worked, all the extra features, they wouldn't have worked on those native products. They had to kind of make their own versions. Now that matters because it means they behave fundamentally differently to if you ran MySQL on your own server or even in RDS. Even upgrades between the versions can have huge changes in how that operates. So even if you've been running RDS for years, and you have got beautiful metrics showing all of your IO, everything's perfect. You go and plug all of those values into the AWS calculator. You go, you know what? We're going to save money staying on standard. Okay, you do that. You switch to Aurora. The behavior of your queries is entirely different. The way that they run, the patterns that they use, the amount of IO that they suddenly take is totally different. Sometimes it can be lower, but generally with Aurora, because of how fast its storage engine is, Aurora quite often will favor like IO and disk reads because of how it works. There's an entire feature called Parallel Query that runs on Aurora that effectively bypasses your entire database engine, if you like, effectively, and pushes the query straight to the storage layer. And the storage layer handles that query. The benefits of that are if you're running an ad hoc query, ad hoc queries in databases tend to flood the cache. Let's say somebody comes in and runs a massive analytics data warehouse type query. That might pull so much data that it pushes out all of your day-to-day, your traffic, your normal data, out of your buffer cache, so your memory that the database thinks it needs. So it will pull that data into the cache, forcing out everything that you actually need. And so then that means that the next queries that come in, now their data's not in the cache, so they have to go to dish, so you get I/O spikes. So to avoid this on Aurora, Parallel Query doesn't do that. It avoids the buffer cache entirely. It quickly works out, hey, this is a new query that I've not seen before. I'm not even going to run this through the buffer cache. I'm going to run this directly on the storage layer, so I don't force the existing data out of the cache. Great. Incredible feature. Really shows the power of the storage layer of Aurora, that you're running queries directly against storage. You're not even, the database is irrelevant at this point. But if you go to IO optimized, AWS aren't daft. If you go to IO optimized, that feature is disabled, because effectively you will be slamming IO, because now you're not taking the buffer cache. You can force everything to run Parallel Query. So in theory, you could effectively avoid IO charge. You could effectively turn IO optimized, push everything down to the storage layer, and then you could totally downsize your Aurora instance, because you're not really using the database engine anymore. Does that make sense? So you kind of get a double win. So AWS blocked it. So just to bear that in mind, that if you are using that feature a lot, that's one more thing to consider before you definitely go to IO optimize, because that feature will be disabled. There's not that many customers use it, to be honest, that use it like regularly. It's a little bit of an edge case, but edge cases are what this podcast is about.
We talked about I asked about a performance related story. I'm wondering, is storage even something customers, do they pay attention to that, or do they focus on the other metrics? Any stories any customer stories with regards to the storage? Any interesting ones to share?
I think Paul's kind of like already gone through sort of like one, like a good customer sort of story about, having that issue, but it is something that we do tend to see. And I think particularly on RDS, I think, as we point out, it's so complicated. I mean, the flowchart, I did put together a flowchart to try and help customers. And I had to simplify it, and I haven't even covered every edge case, because when I tried to do every edge case, I ended up with, it was absolutely huge. There's probably about 50 decision points, and I'm not really exaggerating. It was crazy, because there's different limits per database engine because of how the storage is. So then you have to first work out what database you're running, and that, and then you end up with all the different sporks. So I think that often it's almost too much choice, and therefore I think customers often get a little bit lost in what to do and go, hey, you know what, I'll just click through on the defaults and then I'll worry about that later. And that's fine. Like for most edge cases, just running on GP3 is probably fine. Like if you just spin it up, go with the latest version of the database, like in general, go for defaults. They're defaults for a reason, because they fit most customers. But you're not most customers. Every customer is unique. And there are always people that get caught out. So, I think that's what we're trying to hopefully teach people in this, is that by all means go for the defaults at the start. If you're not sure, defaults are fine. But then look a bit deeper. Go into those storage metrics. Have a look. Are you seeing a nice flat line on top of your IOPS? If you are, you're either IOPS throttled, IOPS bound, or you're instance bound. How do you work that out? Well, have a look at it. Have a look at the value. Go and look at what the max GP3 IOPS would be for your storage you've got provisioned. If your line is much lower than that and is still flat, you're being throttled by the instance type. So, that's sort of what we're really trying to help people understand, because it is complicated. Or obviously, if you're a customer of ours, please raise a ticket, and me and Paul will happily sit there and help you work through it.
Yeah, Jesus Christ.
Yes, as you can see, there's a lot of things going on when analyzing database instance. So usually you need to see a lot of different metrics, and from here start making assumptions and start iterating the issue.
We
But
should have done a whole podcast just on storage, shouldn't we, Matan?
Yeah, like there's so much to unpack, but
Hmm.
maybe like any
Was
other
that a
best
storage pun?
practices.
If that was a storage pun, that was quite good.
I that was unintended,
Totally
but
didn't mean
now
that.
it's hitting me. It's hitting me right. Damn, that was good actually. I didn't even mean to. Maybe some rapid fire best practices for RDS. Even if it doesn't really contribute to cost savings, maybe it'll contribute to less headaches down the road.
Sorry, I completely missed the question. I was reading the next bit.
Oh. No, just any other best practices that you would recommend, and not necessarily cost related, but the the database form of Advil or paracetamol for DBAs.
Yeah, sure. So I think in general, like the really basic ones are things like using like multi-AZ. So multi-AZ means that you have multiple copies of your database. Obviously that doesn't really matter on Aurora. In fact, it doesn't matter at all because it's already multi-AZ. But on RDS, you probably want to use multi-AZ for production. This means if there's an AZ outage or an availability zone outage, which does happen, it's not common, but it does, then your database will fail over to a different AZ and it'll keep up and running. If you're only running a single AZ, AWS will try to just restart that instance for you in that AZ. If it's down, you can't start it. Single AZs are good for non-production. Things you could handle downtime for a few hours for, that would definitely be good to run in single AZ because the costs are effectively halved. But it's also something to bear in mind. There's things known like RDS multi-AZ database clusters, which is a massive mouthful. There you get 2 reader instances and 1 writer, and they run across 3 different AZs. And the difference here is that normally a reader instance, you have to manually promote it. So let's say your writer or your main database goes down. The AWS will not automatically fail you over to the reader. You would have to go and do that manually. Whereas if you're running an RDS multi-AZ database cluster, it will do that for you. It will automatically fail over. It will promote a reader instance and then will automatically promote that to be your writer or your primary. So it's a fairly new feature. Like the DB clusters, I think, only came out last year. So they're fairly new and a lot of people don't know about them. So if you want to look at that, it's almost like making an Aurora of RDS. You kind of have that failover ability, the multi-AZs. So that's definitely a good one.
Yes, I'm thinking about one best practice also that it's really important, that it's to use read replicas. Because I've noticed that a lot of customers usually use one database instance and don't have any kind of read replicas created. And this is something that it's really important if your traffic is mainly based on reads. And usually read queries are the queries that consumes more CPU. So one of the best practice would be to create a read replica and redirect all your read queries to the read replicas. This way, your primary instance will be will have the time, the opportunity to basically ingest write queries. So this is a nice interesting best practices if you want to reduce the CPU utilization for your main instance.
Nice. Another one is around really like the queries. So we haven't really talked about this a great deal so far. We've talked about very much instance level. We've talked about instance right sizing, but actually what your database is doing is probably more important than all of that. If you've got queries that are not optimized, the queries are running really slowly, they will almost always be the thing that's causing your additional needs for IOPS or your additional memory or CPU. So if you can optimize those, you can often find your whole database performance better. I mean, you can often actually go down a database class or an instance size just by doing some optimization. So you can use performance insights. I recommend every single person using RDS and Aurora turns that on. So it's free for the first 7 days. So there's really no reason why you wouldn't. If AWS gives you something for free, take it. And that gives you a graphical interface to allow you to go and look at exactly what's happening in your database at the query level. You can have a look at like the explain plans to see. That should help you identify maybe if you're things like missing indexes, or perhaps you could look into partitioning. Lots of different options. And then in December, a new feature called CloudWatch Database Insights was released. This is for Aurora. Exists for both Aurora, MySQL, and Postgres. And this gives you even more visibility through CloudWatch into those database metrics. In addition, if you're running this on MySQL, just double checking. I think it's just MySQL only for now. No, Postgres, I'm wrong. On Postgres only, you can actually analyze your historical explain plans. So as a DBA, you'll know one of the most frustrating things. Have a query runs fine. One day stops running fine. Everything slows up, causes loads of problems, and everyone's like, I didn't change a thing. Did you? No one changed anything. Real problem. You can now use that to see the historic explain plan that query is run for up to 15 months. So you can actually go and see when the explain plan changed. That gives you an exact timestamp. And if it happened to coincide with an application rollout, you might want to go and have a look. Maybe it's some of the culprits. Yeah, it can be that sometimes. It also you can look at things like if the database has been analyzed, that's a key culprit. The database thinks its data looks like this, so it runs a query in a certain way. that it thinks is optimized. And also analyze come along and whatever does, or vacuum and analyze comes along. The database gets up-to-date metrics about what the data and the histograms and the data distribution, we're getting very deep here, looks like in your database. And it might now go, actually, I think I can run this a better way. But a database isn't perfect and it gets it wrong. And you can actually even help the database. You can put hints. You can help the database go back to the previous one that worked fine. So using that is actually really powerful. And it's something that's only recently become available, like in December, I believe.
Mhm. Yes, another best practice that we recommend is to basically take action in your snapshots, in your manual snapshots that you have been created in the past for your database instances. So let's say that you in the past you needed to do a manual snapshot because you wanted to test anything, or you wanted to upgrade your database instance into a major version. So you created a manual snapshot to have your data basically protected. So what I realize a lot when analyzing customer infrastructure is that usually most of them have a lot of old manual snapshots created, like manual snapshots created for 2 or 3 years ago, and this can cost a lot of money. So a lot of customers doesn't, for example, doesn't pay into or take into account that the billing related to their database resources, as a big part is just for storing this kind of old manual snapshots that they are not even using. So this is something really important.
And before we get into, I guess my last question, any security related? We didn't really touch upon security for RDS.
Yeah, sure. So I think obviously encryption is a major one. Having the database encrypted at rest and also in transit, but encryption at rest might be easier if you aren't already doing it. You can encrypt, if you are running a non-encrypted instance, then you create a manual snapshot and then you can restore that with encryption enabled. So, you obviously need to plan this. It does cause downtime, but it's very much worthwhile.
Yes, I would like to add something regarding security, is that if you don't have your database credentials stored in Secrets Manager, maybe this is a nice time to check if you would need to use this service. Because usually one of the security things when you are audit for your database instances is they ask you, basically the auditors, if you are rotating your database credentials basically in a monthly basis. And you can only rotate your database credentials if you have like a super well-built system that it can support database credential rotating. So if you don't have anything of this setting in place, maybe it would be good to store your credentials directly, database credentials, in the Secrets Manager, because this is a managed service provided by AWS that basically implements, it automates the process of rotating your credentials transparently without needed to do any kind of changes in your code.
One takeaway that I've gotten, and this is something that I learned back at AWS years ago, I had a customer come to me and say, when we move to this managed database service, whether it's RDS or Aurora, when can I get rid of all my DBAs? I don't need them anymore, right? And I think that all of the points and all of the topics that you've raised so far are further evidence that your DBAs may no longer need to go and replace disks on a server physically, or manage operating system upgrade paths and stuff like that, and spend long nights in a data center doing that stuff. But there is a huge amount of work that they can now focus on to make your application, to make your IP better. So we need to go out there and praise our DBAs and make sure that they understand all these, I want to say quirks of RDS, but all these specifics about the way RDS and Aurora work to get the best performance out of your database. They are still very much needed.
Yes, I super agree with this, and also based on my personal experiences, because before arriving to DoiT, before starting working here, I was at DBA for over the last 6-7 years. But we were managing, so I was managing basically our database instances in RDS. So even we had everything in RDS, everything automated, we still had, so the company that I was working still had to hire a DBA. Because one of the most important things that AWS won't automatize for you is query optimization. This is something that a DBA needs to work, because this is something that it's only related to to each application. Each application will execute different kind of queries. And this is something that is different from one company to another one. So even you have everything in AWS, you will still need a DBA because it can save your life, for example, making sure that all your databases will run smoothly.
Is that query optimization thing? Is that overlooked? Is that is that something that it seems like we didn't even get to query optimization until later? So I'm wondering, like, is there so much to look at and manage and keep an eye on that this can be missed for maybe smaller teams or even larger teams?
So yeah, I think query optimization, it really depends on, I think, sometimes the background of the company. So if you've come from maybe a more traditional background where you've had databases running on premises or in data centers, and you decide to move those to RDS, it's likely that you do have that skill and that standard technique of doing query optimization kind of built into your company in general through like your application DBAs. But if you are maybe a digital native or a startup that just needs a database to do some things, you probably don't have that skill set. Like you have like predominantly DevOps engineers or developers. I'm sure they can do SQL, but maybe they don't look at it necessarily from the same depth or the direction the DBA would look at. They're trying to make their query run really quickly, which is fine. But often running quickly and running cheaply or running efficiently isn't always the same thing. And sometimes doing different trade-offs are actually much more beneficial for the database as a whole and the application as a whole. So I think it really depends on like the background of the company and ultimately the skill set. But yeah, doing that like query level optimization is often the best way. If you're not massively over provisioned your instance, if all the really quick, simple wins have been done, then the only way you're going to get better is by query optimization.
Yes, because I've seen also some cases that when things go wrong, basically, the ideal solution that people think it's, okay, let me over-provision the instance, let me increase the storage size. And in the end, they see, okay, this has probably resolved the issue because I don't have more issues, so I'm going to have this instance with this size, so oversized. But what happens is that in the end, they keep oversizing, and this can increase a lot of the cost. So when you usually take a look at the queries that this database instance is executed, and you recommend some kind of indexing strategies to customers, what you see is that the overall CPU utilization reduced drastically. So in the end, the customer, what it can do is basically to scale down the instance. So optimizing queries should be one of the top things that you should take into account always when managing your database instance.
So you're telling me I can't throw more storage at my problems?
Oh,
You can if you've got enough money.
Yeah, I guess you can always chuck money at the problem, but it might not be the right way for profitability.
Oh, certainly hasn't worked for my girlfriend because she keeps buying more and more boxes to put more and more things into, and it's taking up space. Rant over. Last question is, RDS came out in 2009, Aurora in 2014. How has your approach or the way you've recommended customers approach RDS evolved over that time? Like Aurora, just we did an episode on the DSQL, and so are there any assumptions that you have to unlearn over time, or even in the more recent years?
Yes, there's one thing that it's regarding when working with RDS, not Aurora. This only applies with RDS. So, and it's the one storage type that it released on November 2022. So I would say two years ago. So it's recent. And RDS launched the GP3 storage type. Before, there were only one storage type that it was general purpose. So they had only the option to choose the GP2 storage type. And what happened with the GP2 is that in order to get more IOPS, you don't have the power, or the ability to modify the maximum number of IOPS. So in GP2, what it happened before is that if your database instance you wanted to increase the number of IOPS, the only way that you could do this is basically by modifying your database and increasing the storage. Because with GP2, you get 3 IOPS basically for 1 gigabyte. So yeah, the only way in order to increase the performance of your databases, it was over provision your storage. So now, thanks to GP3, customers don't need to over provision the storage. They can basically modify the instance and increase the number of IOPS. So this is something that it was super interesting and made the customers to realize that they could make a lot of changes here.
I think another one for me is finding out that in some situations, Aurora is cheaper than RDS. Even if your RDS is actually configured right, so we're not talking about what Paul's just mentioned about increasing storage to get IOPS. Like-for-like configurations of RDS and Aurora, in some situations, Aurora is actually cheaper. So if cost and absolute cost optimization is your main focus, then I wouldn't just discount Aurora, assuming, oh, it's way more expensive, it's got those more features, because it isn't. For example, I was able to do a fairly simple one, where I was using a MySQL database running an R7G instance, 100 gig of storage, and that would cost about $415 on RDS. I ran this out of London, I think, and it was $315 on Aurora, and that's running IO optimized. So your IO charges are included in the second pricing. So even running IO optimized on Aurora, it actually comes out as less than RDS for like. So again, that's not always the case. If you've got much bigger amounts of storage in Aurora, the instances on Aurora tend to be cheaper and the storage is more expensive. So as you get larger, then Aurora does tend to be more expensive than RDS. But don't necessarily just rule it out. Go and run it through a price calculator first and you might be surprised.
All right. Well, I think that's as much as we can cover on RDS without someone's head exploding. So if you have specific questions, if you work with DoiT, you can open a ticket with Kate or Paul to review a specific use case. If you made it this far, thank you for listening. The code word is cerulean. Message me with the word cerulean, and I will give you a prize for making it all the way to the end. I don't know. I just thought of a random. Sorry.
Wow.
I thought of.
And good luck spelling it.
I was
going
thinking.
to say, yeah.
I was thinking of Pokemon. I was thinking of the badges. Cerulean Gym.
So yum.
Misty, Anyways, thanks for listening. See you the next episode.
Well,
Thanks,
thank you.
guys.
Thank you.
I was going to say pewter. Initially. So,
Pewter?
Crispin knows what I'm talking about.
I do know exactly what you're talking about.
Yeah, okay, thank you. Thanks for the backup.